They look like monsters torn straight from a nightmare. But the truth is far stranger and far more fascinating. In the deserts of Africa, the Middle East, Asia, and the American Southwest, an ancient hunter races across burning sand. It has 10 legs, jaws like bolt cutters, and a speed that makes shadows struggle to keep up. This is the camel spider, also known as the wind scorpion or sun spider. And despite its name, it is not a spider and not a scorpion. Camel spiders belong to a little-known order of arachnids called Solifugae, a lineage that has survived for over 300 million years, long before dinosaurs ever walked the earth. One of the first things people notice is their size. Some species can reach nearly 6 inches in length, and when they run, often at speeds over 10 miles per hour, they appear even larger. But much of what people fear about them is misunderstood. Those terrifying jaws are called chelicerae, and pound for pound, they are among the strongest biting structures in the arachnid world. They use them to crush beetles, scorpions, lizards, rodents, and even small birds. They don't inject venom. Instead, they chew their prey alive, liquefying tissue to drink it like a protein shake. Camel spiders are pure predators. No silk webs, no traps, just speed, strength, and relentless pursuit. They are mostly nocturnal, hiding from the brutal sun beneath rocks, burrows, or even inside human boots. Ironically, despite being called sun spiders, they actually run toward shadows, often chasing humans simply to escape the heat. Their legs are covered in sensory hairs so sensitive they can detect vibrations from prey moving several feet away. And those extra legs you see? They're not legs at all, but pedipalps, used like hands to grab, climb, and taste the world around them. Camel spiders also have an insatiable metabolism. When food is available, they eat until their abdomens visibly swell, sometimes doubling in size. In harsh desert environments, missing a meal can mean death. Perhaps the most shocking part of their life is reproduction. Mating is violent and brief. In some species, the male must physically immobilize the female to survive the encounter, while in others, cannibalism is a very real risk. Despite their fearsome appearance, camel spiders are not aggressive toward humans. They do not seek us out to attack. But if handled or trapped, they will bite in self-defense, and that bite can be extremely painful, capable of breaking skin with ease. No venom, no myths of screaming, no jumping at faces. Just an ancient, hyper-adapted predator doing exactly what evolution designed it to do. In a world of venomous fangs and silk traps, the camel spider relies on something far more primal: speed, hunger, and jaws that never hesitate. And long after the desert cools and the wind settles, they are still running. Long before humans ever walked the earth, before birds filled the skies and flowering plants reshaped the planet, spiders were already here. For more than 300 million years, they have survived mass extinctions, shifting continents, and dramatic changes in climate, making them some of the most successful predators in Earth's history. Among these ancient survivors is one of nature's most remarkable engineers, the orb weaving spider. Orb weavers belong to the family Arachnidae and descend from some of the earliest silk-producing spiders known to science. Fossil evidence preserved in ancient rock and amber reveals that spiders were spinning silk long before the age of dinosaurs. This silk, which is stronger than steel by weight and more elastic than nylon, became the foundation for an evolutionary design that has remained largely unchanged for millions of years: the orb web. Each night, an orb-weaving spider constructs an entirely new web from scratch with astonishing precision. Using up to 7 specialized types of silk, the spider first lays down strong anchor lines, then builds radial spokes, and finally spins a sticky spiral designed to capture prey. The web is not merely a trap, but an extension of the spider's nervous system, capable of transmitting vibrations that reveal the size, location, and struggle of anything that touches it. Orb weavers primarily hunt flying insects such as flies, moths, mosquitoes, beetles, and even stinging wasps. When prey collides with the web, the spider reacts instantly, either delivering a venomous bite or rapidly wrapping the victim in layers of silk. The venom liquefies the prey's internal tissues, allowing the spider to consume its meal efficiently, while remaining safely hidden at the center or edge of the web. Despite their effectiveness as hunters, orb weavers face constant danger from predators including birds, lizards, and parasitic wasps. To defend themselves, they rely on camouflage, rapid web-shaking movements that confuse attackers, or sudden drops from the web while suspended by a safety line of silk. Some species go even further by constructing decoy spiders within their webs, creating false targets that draw attacks away from the real spider. Reproduction is one of the most perilous moments in an orb weaver's life. Males carefully signal their presence by plucking specific rhythmic patterns into the female's web, distinguishing themselves from prey. Even with these signals, mating can be fatal. Females produce silk egg sacs that may contain hundreds of eggs, protecting the next generation before dying and leaving the spiderlings to survive on their own. Orb-weaving spiders play a critical role in maintaining ecological balance by controlling insect populations across ecosystems worldwide. Ancient, delicate, and extraordinarily precise, they rebuild their masterpiece each night, weaving together hundreds of millions of years of evolution into every strand of silk. In the quiet corners of the world, hidden among leaves, bark, and stone, a tiny predator waits with extraordinary patience. Often overlooked because of its size, the jumping spider is one of nature's most remarkable hunters. Found on every continent except Antarctica, these spiders thrive in environments ranging from dense rainforests to dry deserts and even urban gardens. Though they measure only a few millimeters in length, jumping spiders possess abilities that rival some of the most advanced predators on the planet. What sets the jumping spider apart begins with its vision. Unlike most spiders, which rely heavily on vibrations and touch, jumping spiders depend on sight. They have 8 eyes arranged in a unique pattern, giving them nearly panoramic vision. 2 large forward-facing eyes provide sharp, detailed focus, allowing them to judge distance, track movement, and recognize shapes with surprising accuracy. This exceptional eyesight makes them one of the most visually advanced invertebrates known to science. Jumping spiders do not build webs to trap their prey. Instead, they are active hunters that stalk with precision and intent. Slowly and deliberately, they creep closer to their target, carefully calculating distance and angle. When the moment is right, the spider launches itself through the air in a powerful leap. Using a hydraulic system that forces fluid into its legs, the spider can jump up to 50 times its own body length. The attack is fast, accurate, and rarely unsuccessful. Despite their confidence in the jump, jumping spiders always prepare for failure. Before leaping, they attach a thin strand of silk to the surface behind them. This safety line acts as a lifeline, allowing the spider to climb back up if it misses or if danger suddenly appears. Silk, while not used for prey capture, remains an essential tool for survival, providing security and stability in a risky world. Beyond their athletic abilities, jumping spiders demonstrate an impressive level of intelligence. Studies have shown that they can plan routes, remember successful paths, and solve problems that require trial and error. Some species are even capable of choosing longer, more complex routes to reach prey if it means a higher chance of success. This level of decision-making is rare among animals of their size and reveals just how advanced these tiny hunters truly are. When it comes time to reproduce, jumping spiders reveal yet another extraordinary trait. Males perform elaborate courtship displays, waving their legs, vibrating their bodies, and showcasing vivid colors and patterns. These dances are carefully choreographed signals meant to communicate strength and species identity, while also avoiding being mistaken for prey. The female watches closely, and only the most convincing performances are accepted. In the wild, precision and communication can mean the difference between success and failure. Though their lives are short, jumping spiders play an important role in controlling insect populations and maintaining balance in their ecosystems. They are alert, adaptable, and endlessly resourceful, thriving without webs, venomous traps, or brute strength. Instead, they rely on intelligence, vision, and perfectly timed movement. In a world filled with giants, the jumping spider proves that size is not what defines a predator. With unmatched vision, incredible agility, and a mind built for strategy, this tiny hunter stands as one of nature's most impressive achievements. The jumping spider is small, fearless, and perfectly designed for survival. A powerful reminder that even the smallest creatures can be truly extraordinary. In the darkness of tropical forests, when most predators rely on speed or venom, a strange hunter waits in silence. With enormous forward-facing eyes and a face that appears almost otherworldly, the ogre-faced spider emerges as one of nature's most specialized nocturnal predators. Ogre-faced spiders belong to the family Dinopidae, a lineage that dates back over 100 million years to ancient arachnids that evolved alongside early insects. Their unusual hunting strategy developed early and has remained largely unchanged, not because of limitation, but because it is already devastatingly effective. Their most striking feature is their massive eyes, among the largest relative eye size of any arthropod. These eyes are adapted for extreme low-light vision, allowing the spider to detect prey in near total darkness. Each day, the light-sensitive tissue behind the eyes is broken down to prevent sun damage, then fully regenerated by nightfall, giving the spider exceptional night vision unmatched by most nocturnal animals. Unlike web-building spiders, the ogre-faced spider hunts actively. It suspends itself between branches while holding a small, elastic net of silk stretched between its front legs. This net is engineered to expand instantly. When an insect passes below, the spider drops with precise timing, stretching the net over the prey and trapping it in a fraction of a second. Their diet consists mainly of night-flying insects, such as moths, flies, mosquitoes, beetles, and occasionally other spiders. Once captured, the prey is bitten and injected with venom that quickly immobilizes it. The spider then feeds using external digestion, liquefying internal tissues before consumption to maximize efficiency. During daylight hours, ogre-faced spiders rely on camouflage for survival. Their slender bodies and muted colors allow them to resemble twigs or dead leaves, and they remain perfectly motionless to avoid detection. If threatened, they drop instantly on a silk line and disappear into surrounding vegetation. Reproduction is a careful process. Males approach females cautiously, using subtle vibrations to avoid being mistaken for prey. After mating, females produce silk egg sacs containing dozens of eggs, which hatch weeks later. The spiderlings disperse soon after, spreading through the forest using silk threads carried by air currents. By controlling populations of nocturnal insects, ogre-faced spiders play an important role in maintaining ecological balance. In a world where survival often favors strength or speed, this living relic proves that patience, vision, and precision can be just as powerful, continuing its ancient hunt beneath the cover of darkness exactly as it has for millions of years.